Video, yeah, we have to look at what Gay-Lussac's law and Avogadro's what principle. Now, this is one aspect of chemistry calculation that large majority of students have issues with. Who I myself still have had issue with this topic. Then, so I'm going to take this. I'm going to take this video here to explain it step by step, right? And these are the type of question you likely see in your jam exam or your one exam or any other exam at all. As long as what it's chemistry exam and you're involved with calculation, right? You always see this kind of questions to what in the exam. So what I want to do here is so what make sure you pay close attention, make sure you have to pen, your notebook, your calculator, so I can take down every single thing. Do you understand? Now let me say this here. One of the ways you can easily what learn something here, but after you have watched or learned something, the way you master it is by what practicing more, right? And in my video, I try as much as possible to what give you questions under what I've done for you to what to practice, right? So what so many students will do is that after they watch the video, they will know what to solve the question by themselves, right? I don't want to be like that. I want to be an active learner. Now, look at this question here. Question 1 and question 2. They are very common questions that normally occur in the exam. So for every question I solve, I'm going to what replace it with a different value. So I'll be expecting you to solve the question with the value I'll be giving to you. Just and the reason why I'm doing like that, so I want you to master the stuff. So any question you solve, drop your answer at the comment section. Just if you have any question, please drop it at the comment section and I will respond to that. Right? So as we move on, I'll tell you more about our jam class. In case you are not joining our jam class, private class, you have not joined it. As we move on, I'm going to tell you. So now let's understand the Gay-Lussac's law and Avogadro's principle. Gay-Lussac law states that when gases react, they do so in volume which bear a simple ratio to one another, and to the volume of gaseous products, provided all gaseous volume are measured at the same temperature and pressure. That is what for the word Gay-Lussac's law. This last law talk about what the reacting volume, talk about what volume, right? So look at what Avogadro's principle. I'm going to explain two of them at the same time here. Avogadro's principle states that equal volume of all gases under the same condition of temperature and pressure contain the numbers of what of molecule. Just so what you want to understand here is that Gay-Lussac's law and Avogadro's affect only gases. Just affect only what gases, and most element gases exist as well as diatomic. Just so this principle here affects only gas. So you are talking about only gases. Now let me explain to you so you understand the principle here. If for example here we have H2 plus what O2 produce what H2O, right? Now that is hydrogen gas react what oxygen gas produce what water, right? Now let's balance the reaction here. Remember, if you put here and put here, what happens? It is what is balanced, right? Just so it means that two molecules of hydrogen always react with one molecule of what of oxygen gas to produce what two molecules of water. This is called chemical what combination. Just so if you check very well, look at what because they are all gases, gaseous. Again, so in Gay-Lussac's law uses the volume. It means that two volume of this react what one volume of this guy to produce two volume of this guy. Just this is called the Gay-Lussac's law or Gay-Lussac. Is it okay? This is called the Gay-Lussac. Now, for Avogadro's just molecule instead of gases. You understand? So if there's two volume of H2, you're going to be two molecule of H2 react with one molecule of O2, then produce what two molecule of H2O. Do you understand? Now this is called the Avogadros. I guess this is what the Avogadros. Do you understand? So it's very easy. So the goal here is to make sure that you balance what the chemical what equation. So whenever you want to solve question under what the Lusac's law or Avogadro's law or Avogadro's principle here, now you must strike a well balanced chemical equation. Just and so from there you know the what mass of volume that reacted and mass of molecule that reacted. Just so let's take on that. Let's take on that one here. Let's just say N2 gas react with H2 gas to produce what NH3 what gas, right? You have to balance the equation here. If you should put 2 here, then put 2 here. It is what it is balanced. Just if you know how to balance chemical equation, it's very important to learn and master balancing of what chemical what equation. I've done a lot of videos on that. Make sure you learn it because we see in the exam. Now, let's do what the volume first. What does it mean here? 1 volume of what of nitrogen. This is called the ABAP process. ABAP process means what? Is the process by which you produce ammonia gas, right? Ammonia gas is produced for what? For nitrogen gas and hydrogen gas to produce ammonia. Do you understand? So this is what is a well balanced chemical equation. So what does it mean here? That 1 volume react what 3 volume of 1 volume of what N2 the which nitrogen gas react what 3 volume of what of H2O to produce 2 volume of what of NH3. Okay, this for the what Avogadros. This for what for the Gay-Lussacs. Do you understand? Now for the Avogadros here, you have to have what 2. No, you have to have what 1 molecule of what of N2. We have what 3 molecule of what H2. There we have 2 molecule of what of NH3. Okay. Now this is what I'm now going to use. It is this what balance volume and balance molecule you are going to use to solve problem in a chemical what reaction. Do you understand? So we have good question on the board, right? So by the time I finish teaching here, you should be able to master and learn and master this type of question in what water vapor is produced according to the what following equation. According to what to the following what equation. According to what to the following equation. Now look at the following equation here. So look at something here. What volume of oxygen will combine with 10.0 cm³ of hydrogen? So what volume of oxygen will combine with what 10.0 cm³ of hydrogen? Now look at something here. Then I ask here, what volume of oxygen will combine with this one here to produce one here? It's very easy, right? So therefore, let's write our balanced chemical equation out. Right? If you check it very well, you have 2H2 gas plus what? O2 gas give you what? 2H2O gas. Is okay. So from this place here, we know that 2 volume, 1 volume. So since it's already in cm cube, since here is already in cm cube, so it's going to be 2 cm cube. Is okay. 2 cm cube, so it's going to be 2 cm cube. React what 1 cm cube. Produce what 2 what cm cube. Is okay. Hope you understand. So this what is what balance what volume. Balance what volume. Hope you understand. Now, if you check very, if you look at A, what volume of what of oxygen? So volume of what of oxygen? You don't know. It's okay. Question mark here. Now they give us volume of what of hydrogen, right? So volume of what of hydrogen, which is what 10.0 cm what cube. Is okay. So if you check it very well, please check it very well. 2 cm cube of this guy here react with what 1 cm cube of this guy. Do you understand? So you do what you want to do here, because our main focus now is to what is to calculate the volume of O2 that react with this guy here, right? And the only way we can do that here is from this what balance volume, right? So for the balance equation here we have 2 cm cube of what H2 is equals to what 1 cm cube of what of O2. Can you see that? Remember, we are looking for what volume of what of oxygen here. So going to be what? So you're going to be what X. Do you understand? Why you're going to be what 10.0 cm cube. Do you see that? Hope you understand. So if you check very well, if you should what make the formula, this times this divided by this. Hope you understand. This times this divided by this. So you're going to be x equals to what? Here we have 10.0 cm cube times 1 cm cube of what? Of O2 over what? 2 cm cube, right? Now here we have of what? Of H2 is okay. So going to be 10.0 cm cube of what? Of H2. Is it clear? So this times this now, because if you check very, it's just like 2 over what? 1 over 10 equals to what? 1 over what? X. That is just how it is. Hope you understand. So this 2 cm cube of H2 react to what? 1 cm cube of O2. That's why you say this is equals to this. So that they gave us what? Volume of H2. They now say what volume of O2 will react. Do you understand? Just like what? Compare this, you are comparing them. Do you understand? So what I've done here is this. What I've done here is that if I should what? Make this S itself from like S going to be 2S equals to what? 10 times 1, right? Divide both by what? 2. It's okay. My S goes to what? 10 over 2, which is what? Is 5. Just that is new. So if you should use that here, if you should what? Make S itself from like this times this divided by this. Hope you get it. So you have S equals to what? 10.0 cm cube of what? Of H2 times what? 1 cm cube of what? Of O2 over what? 2 cm cube of what? Of H2. This is that. What will happen here? This will cancel out this guy here, right? So what will happen? You go to your 10 times 1 cm cube of what? Of O2 over what? 2, right? This is going to this here, right? 5. Here going to this here, which is what? 5, right? 5 times 1 cm cube of going to be 5 cm cube of what? Of O2. Do you understand? It means that what it means that 10 cm cube of H2 reacts with 5 cm cube of O2. That is meaning. What does it mean here? It means 10 cm cube of what? Of H2 reacts with 5 cm cube of what? Of what? 5 cm cube of O2. That is, this guy is half of this guy here. As you can see here, yes, 2, yes, what is 1. Just that is. So we are done with what? This one here. Hope you understand. Please, if you understand the first one here, please leave a comment section that you understand the first one. Please leave a comment section that you understand what the first one. It's very important. Please leave a comment section that you understand the first one. It's okay. So we are done with what the first one. Let's look at what the second one be. Right? They say how many cm cube of water vapor will be produced under the same condition. Right? So why this place at? Why this place at now? Please pay attention here. Remember, we are still going to use the same volume of what? Of hydrogen gas. The volume of hydrogen gas is what? 10.0 cm cube. So it's going to be volume of what? H is what? 10.0 cm cube. Is okay. Please pay attention here. Now here, what do you have here? So that's now volume of what? Of H2O. Idea. So I have to compare these two of them. 2 cm cube of. So I have to compare this one here. 2 cm cube of H2 equals to 2 cm cube of what? Of water, right? So 2 cm cube of what? Of H2 equals to what? 2 cm cube of what? Of H2O. Is okay. So this is what they say should look like. So here will be what? X. Here that become what? 10.0 cm cube of what? Of H2. So what I want to do here is make X solid formula here. So X equals to 10.0 cm cube of what? Of H2 equals to what? 2 cm cube of what? Of H2O over what? Right? 2 cm cube of what? Of H2. What happened here? This we cancel out this one here, right? 2 going to 2, right? What we left is what? Is 10. So your answer is going to be 10 cm cube, right? So it will be 10 cm cube of what? Of H2O. That is it. So you can see that it's not that difficult here. So if I change here to now question 1 here, right? Let me change the value. So if I change here to 38.6 cm cube, right? Pause the video and do this work number 2 for me. It's okay. Or after the video here, you do it for me, right? So we are done what with first one here. The first one we pave way for this guy. It's okay. Very important. We pave way for this one here. So process ammonia is produced by herbal process according to the what, to the equation. Look at the equation here. So let's write that. Say we have what, N2 gas plus what, 3H2 gas. Then we now have what, 2NH3 what, gas. Is okay. That is it. So look at something here. Remember, here we have what, how many volume? Here we have what, 1 cm cube, right? Here we have 3 cm cube, and here we have 2 cm cube, right? So let's look at, if you look at the question here, is that if 2 cm cube of nitrogen were mixed with 90 cm cube of hydrogen under stable condition, right? So if you check it very well, volume of what, of N2, volume of N2 is what 20 cm cube, right? And volume of hydrogen was what, volume of what, H2 is what, is 90 cm cube. Is it clear? Which gas is in excess and by how much? Just so look at something here. We have called limiting reactant and reactant in excess. So for every chemical reaction, if you have two reactants and you give they have their each of their individual volume, right? When two of them react together, one will be excess, one will be what, limited. Now the one that is limited is what that will be used up in a chemical reaction. While the one that will be excess will be the one that will remain when the reaction stops. So how do you do that? How do you know the amount, the one that will reduce up and the one that will remain? Look at something here. Remember, volume of N2 is what, is 20 cm cube. That is this react to this here, right? So here we have 90 cm cube. Now what I want to do here is to use this one here to calculate the mass of this guy here. You want to know you want to know if 20 cm cube reacts with this guy here. You want to know the amount of this guy that reacted. Just I want to know the amount. If you look at here, what volume of oxygen we combine, right, with this guy here. In our first question here, we use 10, right? So now have to say what volume of N2 we combine this one here to put this one here. Do you understand? That is what is the exact volume of N2 that will react to this guy. Now here they gave us 90, but we don't know if it's 90 that truly what reacted. The only way we know if 90 truly reacted completely or not is by calculating what the mass of this one here with this one here. So what will happen here is that now remember here we have 1 cm cube of what N2 is equals to what 3 cm cube of what, of H2. Is it clear? Now you want to calculate what the volume of this guy that actually what reacted with what 20 cm. So here we have 20 cm cube of what, of N2 equals to what, X. Now why do we put X here? Now when 20 cm cube of N2 react with this guy here, what amount of this guy actually what reacted? Although we may be giving 90 cm cube, but we want to know the amount that actually what reacted. Is by calculating, is after you calculate for here, do you now know the one that will be excess and the one that will be limited? Do you understand? So yeah, let's calculate this guy here using the method you have been using, right? So if you want to make X the subject of formula here, what do you get? X equals to what? This times divided by this, right? So it will be 20 cm cube of what, of N2 times what, 3 cm cube of what, of H2 over what, 1 cm cube of what N2. Can you see that? Because this guy will cancel out this guy, right? So my X equals to what? My X equals to what? My X equals to what? 20 times 3 cm cube of what, of H2. What will happen? You're going to do what? 20 times 2 is going to be 60 what cm cube. Do you understand? So please pay close attention here. It means that the volume of H2 that actually what the volume of hydrogen that actually reacted with what 20 cm cube is 60. So here you can see that it means 60 cm cube of what of H2 reacted or combined reacted with with what 20 cm cube of what N2. Do you see that? What does it mean here? It means that the volume of N2 is being used up completely. That is, you use H completely, right? So 20 cm cube of N2, that is nitrogen was used completely, was used up in the chemical reaction, right? Now, the one that the amount of H2 that you got this guy here, although 90 was given to us, but the amount that actually what reacted is not up to 90. Just it is 60. That is mean. It is what is 60. Just so that was it means that 60 cm cube of H2 reacted with 20 cm cube of N2. Just so if you look at the question again, that which gas is in excess and by how much? Now the gas that is in excess is what is H2. So you can see that the gas in excess, is what H2. That is gas that is in excess. Why is it in excess? Because only 60 of these two of H2 reacted with 20 cm cube of N2. Just that is the reason why. Right? So that is why you see that H2 now 90 was given to us, but only 60 reacted. Only 60. Please, I want you to understand it here. Only 60 reacted. How do we get the 60? By using the volume of N2 to calculate what the mass of our H2. So that's how we got our volume of H2 that what reacted. Just it means that the gas in excess is H2. By how much gas is left? We say by how much. So how much by how much gas is left, right? By how much? So by how much is in excess? So excess what? But excess is equals to what? It's going to be what? 90 cm cube minus what 60 what cm cube. It's okay. So which is what is 30 what cm cube. So by how much? So they're asking which of the gas is what? Which of the gas is in excess? Which is what is H2? By how much? So what to do there is to subtract this one calculated from this guy. Is okay. Excess. So the excess is what is 30 what cm cube. That is it. 30 what cm cube. So look at something here. So yeah, what does it mean here? From this place here, let me wipe the whole board here. So take that from here. So from here you can see that. So they ask here which of the gas is in what limited. So here you can see that the limiting gas is equals to what is N2. Right there. So now why is it N2 the limiting gas? It is what that is being used up because 20 cm cube of N2 is reacted completely. That is being used up, right? The excess gas is what H2. Right there. I make sense here. Amount in excess is what is 30 what cm cube. Is it clear? So that is we have calculated what we have calculated what the A, right? So from the A, when they say calculate again, they say what will be the volume of ammonia produced? What will be the volume of the ammonia produced? Look at something here. To calculate the volume of ammonia produced, you use what the volume of what of N2. Just because 20 cm cube react to only what 60 cm cube. So what is the amount remaining? Remember, 30 is in excess. 30 of this guy is excess. So we want to know the amount of this guy that is being produced in a chemical reaction. Do you understand? And the only way you can use the only way you can get what the amount of NH3 or the volume of NH3 produced is by using what the volume of the limiting reactant. So the limiting reactant will always be used to calculate what the volume of the product produced in a chemical reaction. So this one what you need to know when you have solving this kind of question. Hope you understand. So from here now, so here we can say what 1 cm cube of what of N2 is equal to what? Here we have 2 cm cube of what of NH3. Is it clear? So yeah, here is what is 20. Here we have 20 cm cube of what of N2 because of what X. So now let's make X subject of formula here. Like let's calculate X. X is what is volume of what of ammonia produced. This is that. So that's going to be S equals to what 20 cm cube of what of N2 times 2 cm cube of what of NH3 over right 1 cm cube of what N2. What will happen here? This one cancel out from here, right? So it's going to be 20 times 2, which is what 40. So here we can now say what volume of what of NH3 produce equals to what is what 20 times 2, which is what going to be what 40 cm cube of what of NH3. You see that 40 cm cube of what NH3, as easy as that, right? So we are done with this guy here. Right? Now look at what the last one. What is the total volume of gas mixture at the end of the reaction? Look at something here. At the end of the reaction, this guy was produced, so it remained in the reaction, right? Now 30 cm cube was in excess, right? So yeah, let me just find this place here. So what will now happen here? Please pay attention here. That is the total volume the total volume of the mixture at the end of the reaction is going to be what? The volume of what NH3 produced, while the volume of what of excess of what N2 that is remained. So volume, or you can say total volume, total what? Volume. Is okay. Total volume of mixture. Is okay. Total volume of mixture is what? It's going to be 30 cm cube plus 40 cm cube. You're going to get what? 30 what cm cube. Do you understand? So this is about Avogadro's law. And what Avogadro's principle and what Gay-Lussac's what law. Just this is what is the calculation, and this type of question you likely see in the exam. This type of question occur every single year in cut across chemistry exam. Just so I believe this video is helpful here. So what I want to do here is to change value. Let us say here we have what 15 cm, and here we have 64 cm cube, right? Let us say cm cube, right? So we just change value here. This value here to solve what this question here. And some of you have bad habits, you ignore it. If you ignore it, that is your own cup of tea. You still be the one to face it in the exam. So I will advise you, try and pause the video and use your brain and solve it. Just go over the video again and solve it, and make sure you want to get the answer. Just I hope this video is helpful. If this video is helpful, please leave a like message. This video is helpful. See you in my next video.